Today's lesson is a continuation of mixed numbers and improper fractions. Students will convert mixed numbers and improper fractions, use multiplication to find the improper fraction equivalent to a given mixed number, and use division with remainders to find the mixed number given with corresponding improper fractions. On your Power Learning dashboard for today's lesson, you will find model notes that you're welcome to print and download to help you remember the steps that you need. And there's also an extension activity for the end of the lesson if you finish early. Let's jump in here then. So how many quarters are in one pie? Well, we know that there are 4 quarters in one pie. So we have 4 quarters here. How many quarters then would be in 2 pies? Well, if I had 2 pies, there would be 8 quarters. And how many quarters would be in 3 pies? Well, there would be 12. How am I figuring this out? How am I doing this math so quickly? Well, I'm multiplying because here I have 1 pie, there's 4 quarters, I know there's going to be 4. If I have 2 pies, and I know that each pie is cut into 4, I'm going to do 2 times 4, which is going to give me the 8. And for 3 pies, I'm going to do 3 times the 4 pieces, and that's going to give me the 12. So I'm using multiplication to figure this out. Now, how many quarters would there be in 3 1/4 pies? So here, if I showed you this picture of 3 1/4, well, I can multiply the 3 times 4 because there are 4 pieces in each pie. That's going to give me 12 pieces. And then I add on this last piece for 13. So the improper fraction here to show you, or sorry, the mixed fraction here to show you would be 3 full pies and 1/4. This 3 here is standing for 3 full pies. This here represents the extra piece. And then the 4 represents how many pieces each pie is cut into. So there are how many quarter pieces altogether? There's 13. So to find this, all I've done is I've taken this 4, I've multiplied it by the 3 to get 12, and then I added the extra piece. So 4 times 3 plus the 1 gives me 13 quarter pieces all together. Now, how many halves would you have in one pie? Well, if one pie is cut into halves, then there's going to be 2 halves. So I've done 1 times 2. If I have 2 pies that are cut into halves, I'm going to do 2 times 2. There's going to be 4. If I have 3 pies cut into half, I'm going to multiply 3 times 2. It's going to give me 6. Now, if I have 17 pies and I multiply that by 2 because they're cut into halves, I'm going to end up with 34. So then how many halves are there in 1 1/2 pies? Well, I have I have 1 full pie and then I have a half pie. So there's going to be 5 halves. Sorry, 3 halves. I'm getting ahead of myself here. There's going to be 3 halves because I have 1 full pie cut into half and then I have another pie cut into half. So I would have 3. If I have 2 1/2 pies, well, I know that 2 times 2 is going to give me 4, plus 1 is going to give me 5 halves. What if I have 3 1/2 pies? Well, I can take 3, I can times it 2 by 3, and then I can add the extra piece. So 3 times 2 is 6, add 1, I have 7 halves. The same theory goes for here. So if I have 4 1/2 pies, how many halves am I going to have? I'm going to do 4 times the 2, which is 8. Then I'm going to add on my extra piece, which is 9. If I have 20 1/2 pies, I'm going to do 20 times the 2, and then add the extra piece on here. So 20 times 2 is 40, add the 1, I'm going to have 41 halves. Now, how many halves are in 8 1/2 here? So I've drawn out the pies for you. You can either count them, or you can do what we've been doing this whole time and do 8 times the 2, and then you add on the extra piece. So 8 times 2 is your 16, and then you add on the 1, so there would be 17 halves in 8 1/2 pies. And if you want to check the math, you can just count the pictures here below. So I want to just emphasize before you begin this that the extra half is just one more piece. So once you know how to multiply the numerator and the whole or the denominator and the whole number, you're just adding that extra piece on. So here is some exercises for you to do on your whiteboard. How many halves are in 2 1/2? Remember our trick. You're going to take the denominator, times it by the whole number, which is 4, and then add on the extra piece. So there would be 5 halves. Okay, continue on with B, C, D, and then resume your screencast. Now, if I want to do the same thing for thirds, how many thirds are there in 1 pi? Well, if I have 1 pi and it's divided into thirds, I apologize for my drawing, pretend these are equal, there's going to be 3 thirds in 1 pi. But now, what if there are 2 pieces? Well, I'm going to take the 2 and I'm going to times it by 3 because there's 3 pieces in each pie. There's going to be 6. I'm going to do the same here. If there's 3 pies, they're cut into 3 pieces each. I'm going to times it by 3. There's going to be 9 thirds. Okay, you could continue on with all these numbers just by multiplying by 3. But now if I turn these into a whole number, mixed numbers, now what do I do? Well, same thing that we were doing before. You're going to take your denominator, you're going to times it by your whole number, and then you're going to add the extra piece. So if I have 2 times 3, that's 6, plus 1, there's going to be 7 thirds. Continue on with B, C, and D. Then resume your screencast. Great job. So let's now introduce word problems with a context. So there are train cars that hold 4 vehicles each. What fraction of a train car is each vehicle? So let's draw this up. My train car, I'm going to use a rectangle. This is my train car. Okay, my train car holds 4 vehicles. So if it holds 4 vehicles, I need to divide it first in half. Then I would divide it again in half on each side because it needs to be into fourths. Pretend those are equal. So what fraction of a train car is each vehicle? There's a fourth. Okay. Now, how many fourths are in 2 wholes? So if I had 2 train cars, this is 1. If I had another one, how many fourths are there in 2 wholes? Well, there would be 8. I'm taking my first train car, I'm going to times it by 2, and it's going to give me 8. Now, let's do some exercises. We'll do A together, and then you're going to try and B, C, D on your own. So train car holds 4 vehicles. So I've drawn out your vehicle here. How many vehicles will 1 1/4 train cars hold? So you have a full train car here already because you know you have 1 whole. So this train car, is full of vehicles. So you have 4 vehicles. Then in your second train car, you have 1/4. So how many trains or how many vehicles are going to fit into 1 1/4 train cars? Well, you would have 5. If you need to draw a picture for B, C, and D to do so, please do, and then continue on with your screencast. So you should have found for B that the train cars can hold a total of 11 cars. For 2 1/4 train cars, you should have found the answer to be 9, and for 1 3/4, you should have found the answer to be 7. Let's do these exercises together. A bigger train car can hold 6 vehicles. So now you have 1 train car, and it holds 6. So we need to divide this into 6. Okay. So now I'm going to go 3, 4, 5, 6. So there's 1 train car. How many vehicles will 1 and 5, 6 train cars hold? Well, we could do it with a picture. We could double this picture, or we could take our trick that we learned and do 6 times 1, which is 6, and then add on those extra 5. So 6 times 1 is 6 plus 5, it would hold 11 train cars. For B, an even bigger train car holds 8 vehicles. How many vehicles will 2 and 3/8 very big train cars hold? Same thing. Let's do 8 times 2, which is 16, and then add on the 3. So it would hold a total of 19 cars. So this is what the trick we've been using, and you can download this model notes page from Power Learning to help you on your exercises. So if I want to convert this mixed number 2 and 3/8 into improper fractions, I'm going to take the denominator, which is 8, and I'm going to times it or multiply it by this whole number. So 8 times 2 is 16. Now I'm going to take 16 and I'm going to add on the numerator. So it's going to give me 19. Now the denominator is always going to stay the same from what you started with, because that is what your pieces are cut into, or what our train can hold from the problems before. So that your denominator always stays the same. So your improper fraction would be 19/8. So let's look at this model. So we have 3 3/4. So we have 3 full pies and then 3/4. How do I change this into an improper fraction? Well, you can either count all these pieces, or you can do it the way I've been teaching you. So you could take your denominator times your whole number, which is 4 times 3, which is 12, and then add on your extra 3. So it's going to be 15 over 4, because each pie is cut into 4, and that was the denominator we started with. Remember, the denominator never changes. So here's some mixed numbers that I want you to change into an improper fraction. If you need to download that model notes page to have it as a reminder on your desk as you do this, please do so. When you're done, you're going to resume your screencast. So now we're going to write a mixed number and an improper fraction for these pictures. So let's start with the mixed number. So how many pieces here are we given in total? Well, we are given we are given 1, 2, 3, 4, 5, 6, 7 pieces. And each pie is divided into 2. So that would be our mixed number, or sorry, our improper fraction. For our mixed number, we can see that we have 3 full pies, and then we have half of the last pie. So that would be our improper fraction, and then our mixed number. We can do the same for the triangles. So we have 1, 2, 3, 4 triangles in each bigger triangle. So we know our denominator is always going to be 4. And then we have 4, 8, 9, 10, 11 shaded for the improper fraction. Then for the mixed fraction, we have two holes, and then we have 3/4 shaded in of the second one. So we can easily get both the improper and the mixed fraction when we're given a picture. Now let's write improper and mixed numbers for these. So here we're given a measurement and a line. So what is the length of this line? Well, if 3 blocks is 1 meter, then this would be 2 meters, this would be 3 meters, and then we're left with just 2 blocks instead of 3. So our whole number would be that we have 3 full meters, and then we have 2/3 of the next meter, because this would have taken us, these 3 blocks would have taken us to the next 4th meter, but we don't have all 3, we only have 2. For our improper fraction, we could say that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 blocks, and each meter is still divided into 3. Our denominator always has to be 3. So those would be our 2 fractions we could get there. Now for this one, we could say we have 3 full liters, and then we have 2/4 of that 4th one, or 1/2, either or. Or if we want the improper fraction, we have 4, 8, 12, and then 13, 14 total over 4. We're always dividing into 4. So here you're going to write each whole number below as an improper fraction with a denominator of 2. Show your answer with a picture and a multiplication statement. So let's look at A together. So we have a whole number of 3, and I need to divide it by 2. So my denominator is going to be 2. I'm going to take that whole number and multiply it. And then I drew the picture. So now for 4, if I wanted a denominator of 2, I need to times the 4 by the 2. So I'm going to get 8 over 2. And if I drew this picture, I would have 4 pies here divided each into 2. Now, if I have the improper fraction of 10 over 2, how do I find the whole number of pies it represents? So how do I go from an improper fraction to a mixed number? Well, I know that if I drew this picture out, I would have pies that are divided into half. So if this is my pie, and I divide it into half, that's going to be 2. I can copy it. That would be 4 pieces. Then I would have 6 pieces, 8, 10. So this would show me that I have 5 whole pies.